Oh hey, I didn't see you there. Welcome to another installment of DSAW's Awesomely Bodacious Science Show!
Believe it or not, it's the Darren Show. I'm Dr. Darren, I'm doing science. And doing the science, I'm Dr. Darren. I have a PhD. Believe it or not, it's me.
Hi, welcome to another episode of Darren's Awesomely Bodacious Science Show. Today, we're going to be looking at physics, more specifically, forces, and even more specifically, Nerf guns. If you don't know how a Nerf gun works, it essentially works like this. There's a spring in the back in which you pull. It then builds up pressure in this thing called the air chamber. And once you press the trigger, all that pressure is released into the Nerf dart, and it will then shoot. I basically have two free body diagrams over here to show you the 2 points I decided to use. One of which is when it's mid-air and it's only being affected by gravity, so it's like slowly falling down. The other of which is the instant when shot out the barrel. You get all the force loaded into the dart and shot through the barrel, and it's only affected by the applied force of the spring and gravity. So with that, let's get on to our stats. I've shot around 50 darts through a chronograph, and I've averaged around 15.65 meters per second, which is honestly pretty fast, even though it's a Nerf gun. I also measured the barrel at around 8 centimeters, and I actually got the compression of the spring at around 6.5 centimeters. And now that we've got all that data and stuff out, I'll bring it over to my assistant, who will show you the work for my next part.
Thank you, Darren, for the segue. It is I, Darren Lee, PhD, here to show you our first problem. Our goal for this part is to find a forces problem that uses the information we already have. So we have decided to calculate what kind of spring you need to launch a Nerf dart at 343 meters per second. Or the speed of sound, basically. In this case, we're ignoring weird friction and the fact that putting all the force on a Nerf dart will probably shred it to pieces, so we can have fun. If you know a thing about guns, you know that a bullet, or dart in our case, will keep accelerating until it reaches past the barrel, in which then it will fall to the ground. We know that our current Nerf dart has a mass of about 1.3 grams, and the barrel is 0.08 meters long. And the spring is 6.5 centimeters, which we will change to meters later on. And that's pretty much all we need to know to start. To reach the speed of sound, we need our dart to accelerate from 0 to a speed of 343 meters per second by the time it exits the barrel. So the average velocity will be 171.5 meters per second. We can then divide the distance by that to get a time of around 1/20th of a second. I'll be putting up all the data on the screen so you can follow along. We can then divide the change in velocity, which is 343 meters per second, by the time to get our acceleration. The acceleration turns out to be around 700,000 meters per second squared. Since we have acceleration, we can then find force by multiplying the acceleration by the weight of the dart, which as I said is around 0.0013 kilograms to get our force of 956 newtons. We can then plug that into Hooke's law with a spring displacement of 6.5 centimeters to get our spring constant of 14,706.13 newton meters, which is roughly 1,600 times stronger than our standard Nerf spring at 9 newton meters. We interrupt this programming to bring you a sneak peek at the summer's new blockbuster. Darren, it's me, Obama. I need your help. We've been teleported to a mysterious planet, and you need to take down the orbital satellite to get us out. That's the plot of the movie. You have to do this. Oh no, I'm getting a heart attack. Bullets won't work on that ray shield. Only a Nerf dart will. I must use the formula to find the escape velocity. We have to use that velocity to get our new acceleration. Multiply that by the mass to see if we have enough force. I have no choice. I have to rearrange Hooke's law to find the spring constant. $8 million Newton meters. This one's for you, Obama. I did it. The dart breached the gravitational pull. I have saved the world, and more importantly, my physics mark.